Here I have another graph. I probably should have put this at the end of the last video, but I forgot, so let me quickly talk about it. Because sometimes you gotta have a situation like this, where here's your graph. This dashed line is called a vertical asymptote. Hopefully you remember about asymptotes from algebra. You know, asymptote is where your function or your graph approaches and gets very, very close, but never ever touches or crosses this dashed line. So then you may be asked, well, what's the limit in this case as x approaches 4? As a matter of fact, just to be clear, a lot of times the graph will look like that. So they give you this function graphed and they say, what's the limit as x approaches 4? So you say, well, when I come from the low side, as x approaches 4, what is my graph approaching? It's basically infinity. And the same thing if I come from the high side. Well, when we're looking for limits, we're looking for the limit to equal a number. And infinity is not really a number. I mean, it is a number, but not really. So in this case, once again, this is a case where it's undefined. When we're looking for a limit, we're looking for the value of the function to approach a number. And here it doesn't approach a number, it approaches infinity. All right, so now let's get on to our main topic. I guess I can call it sort of, if you're given some kind of a function as an expression, how do we calculate the limits mathematically? We've looked at, if we're given graphs, how to determine limits, but how about just looking at a function? Now here's the key. No matter which kind of function you're given, there's going to be only 3 I could say types of answers. One, if you take the limit of a function as it approaches, I'll just put c here. C just means a number. Could be 1, could be 5, could be -10. The first thing that happens is you take the limit of a function and it just equals a number. It could equal 1, could equal 7, could equal 3.5, could equal -10. All right, that'll happen. We take the limit equals a number. Here's the second thing that could happen, and you won't understand this right now until I do some examples, but just roll with me on this. This one, you get a number, very straightforward. This one, you actually start to do the math, and before you know it, you end up with this sort of special, sort of funky situation where, in this case, your function is like a fraction, and you start to evaluate the limit mathematically, and you end up with a case where you have 0 divided by 0. Now in a minute, there's something we can do about this to still try and solve for the limit, and we'll talk about that in a minute. But sometimes it happens. And then if neither of these things, so the first thing that happens is just the limit equals a number. The second thing, in some funky way, the limit is 0 over 0. And the third thing that can happen is, once again, you end up with a fraction. And you have some kind of a number, something other than 0. But in the bottom of the fraction, you still have 0. If you end up with this, of course, a number divided by 0 is like undefined, which basically means you're going to have your limit is also undefined. So all the functions where we try and take a limit, one of these three things are going to happen. The limit's going to either equal a number, the limit is going to be 0 or 0, and we're going to talk about what to do with this, or the limit is going to be a number divided by 0, which means undefined. So let me talk about, you're given a function, you're asked to find the limit as x approaches a number. How do you actually do that? Because when you do it, then all of a sudden, one of these three things will happen. And the good thing is, it's actually very, very simple to start the process of defining the limit. You're asked, just to make it clear, you're given a function and you're asked to determine the limit as x approaches to of f of x. The first step is here's how I phrase it. The English might not be perfect, but I'll explain to you what I mean. The first step is you actually plug in the number for x. In other words, I've got this function. They're saying, what's the limit as x approaches 2? First step, you just go ahead, whatever limit your x is approaching, just go ahead and plug that number in for x of your function. This is the first step you always do. As a matter of fact, let me write down, I'm going to calculate 4 different limits of functions that will illustrate what can happen. Let me actually just write down the 4 first I'm going to do in a minute. I'm asked to find the limit as x approaches 5 of this function, 2x plus 3. The second problem I'm going to do, the limit as x approaches 2 of this is actually a rational expression, right? It's a fraction. So here are the 4 problems I'm going to work through. Now what's interesting is for this third one, I actually have the same function as the second one. The only difference is this one I'm looking as the limit as x approaches 2. This one, the only thing that's different is I'm looking at the limit as x approaches 1. The function is the same. And then the fourth one, the limit as x approaches 1, looks a lot like these two, but not quite the same, x squared over x minus 1. So for limit problems, first step is always the same. You simply, if this first one, x approaches 5, you simply plug in 5 for x into your function and see what happens. Right? So like this right here is the function. I'm simply saying whatever x is approaching, you plug that number into your function. When you do this, when you plug in whatever number x is approaching, you plug it into the function, and it just equals a number, any number, then you're done. And you would say the limit as x approaches 5 of 2x plus 3 equals 13. All right, that's nice when that happens. You just plug in the number for x. If this whole thing equals a number, you're done. Well, let's look at number 2. So here's my function. I'm taking the limit as x approaches 2. So I'm going to go, every place I have an x in my function, go replace it with 2. So I have 2 squared minus 1 2 squared minus 1 over 2 minus 1. So what is this? 4 minus 1 is 3. You know what? Once again, you plug in this number for x. Whatever x is approaching, you just go ahead, plug the number into the function. If you get a number, once again, that's your answer. So if I wanted to, I could just go over here and say the limit as x approaches 2 of this expression is 3. The third one, first step's always the same. Here, x is approaching 1. First thing I'm going to do is I'm going to go to my function. Every place I have an x, I put in a 1 and see what happens. So in this case, I have 1 squared minus 1 over 1 minus 1. 1 squared minus 1 is 1 minus 1. That's 0. 1 minus 1 is 0. All right. So now for this one, when I plug in my number for x, I do not get a number. Matter of fact, I get sort of this funky situation where you have 0 divided by 0. And you know what? In the world of math, you can't really, no one knows how to take 0, to take nothing, and divide it by nothing. That's one of those, it's like it's impossible. But here's what you do. Okay, these two were the first possibility. Remember I said there's 3 things that can happen. If you're asked to find the limit, sometimes you plug it in and it's just a number and then you're done. That's what the first 2 were. We plugged in the number for x, the function equal to number, we're done. But then I said sometimes when you go try and figure out the limit, you plug in the number for x and you get 0 over 0. Actually, here's I grabbed the wrong thing. Sometimes I said when you plug in the number and it turns out you get 0 over 0. And then I said, what did we do here? Well, now we're going to talk about it. What you can do that sometimes works is you go back to the original function, and sometimes, just so it turns out, if you go back to the original function and you try to do some factoring, then some interesting things happen. So, here's number 3 again. We went ahead and plugged in the number, but we got 0 over 0. So that was like, well, that didn't help us, but that tells us, okay, the only thing left for me to try is I go back to the original function and see if something factors. Now I've got a top and a bottom of this fraction. I notice the top, x squared minus 1, actually is a difference of squares. It can be factored. Ends up being x plus 1 times x minus 1 all over x minus 1. Now sometimes when you factor, look what happens. I have identical parentheses in the top and the bottom. These are identical factors. Now what's interesting is my first attempt, when I just plugged in the number into the function, I got 0 over 0 and I was sort of stuck. So I decided to go back and try and factor, and once I see that the numerator factored and then I can cancel, now I go back and I'm going to take this and try it again. I'm going to plug in the number again. So in this case, as x approaches 1, let's plug in 1 for x. You end up with 2. And since it's a number, we can stop and we're done. So let's review what happened. First step's always the same. If you're trying to take a limit, you take the value that x is approaching, you actually just plug it into your function. You're hoping it's going to be a number, but in this case it's not a number, it's 0 over 0. So you say, okay, when I get 0 over 0, what I can do is I can go back to my original function and see if it factors. Here's the original function, and I realize x squared minus 1 does factor into x plus 1, x minus 1. And then after I factor, I realize, hey, I have identical parentheses at the top and the bottom. I can cancel those out. And then once I take whatever's left, I go ahead and try the limit again. So I set x equal to 1, but in this case, instead of getting like 0 over 0, I just get a nice number, which means I'm done. So the limit, actually, to be totally correct, go back to my original question. The limit as x approaches 1 of x squared minus 1 over x minus 1 equals 2. Once again, the way I got that is, once I realized that 0 over 0, I went back to my original function, tried to factor it. After stuff cancels out, I was then able to go back and calculate the limit of the function. So this is an example, number 3, of that second possibility. The first two was just where your limit equals a number. The second, or the third one, when you plug in the number, you get 0 over 0. Now, let's see if we get an example of this last one. So let me redo 4 down here. So here's first step is always the same. Whatever number x is approaching, go and plug it into your function and see what happens. In this case, x is approaching 1, so f of 1, which is going to be 1 squared over 1 minus 1. So the function, when you plug in x equals to 1, is 1 over 0. So that's actually the third thing I said that could happen. But in this case, is whenever you get a number divided by 0, you know that's undefined. So right away, you know there's not going to be a limit. You know, in this other case, when you get 0 over 0, that's also sort of like undefined. But we could go back and do some factoring and canceling. But it turns out when you get a number over 0, you're sort of stuck. You can't go factor, you can't do anything. You just have to say there is no limit. All right, so that's what's going to happen. You're going to be given functions like this. These are the functions, and you're going to be asked to take the limit of those functions as x approaches a number, and it's actually not that difficult. The first step is you plug in the number into the function, see what happens. Whatever happens will then determine what you do next. Now, one more thing to look at mathematically. These are all single functions. But sometimes they may give you a problem where they want you to find the limit of what we call a piecewise function. If you remember from algebra, piecewise function, it's almost like if you were to graph a piecewise function, it's almost like either there's a break or a gap or somehow the graph changes drastically. It could be like this. It could mean like your graph is a straight line and then you get to here and it becomes like a curve. It's almost like there's two parts of this graph and they're just put next to each other. Sometimes this happens. Once again, this is sort of the value of x where things change. Although in this case, when things change, there's a gap there. Just out of interest, look at these graphs. If we were asked to find, say this is 2 right here. So this is my function. Before we look mathematically, let's just look at these two from a graphing standpoint. If we were to look at the limit of this function as x approaches 2, what would we say? Well, since we have a graph, we need to look at it both from the low side. So it looks like, maybe say this is like 4. So from the low side, the limit's 4. From the high side, the limit's 4. Since those two limits approach the same value of the function, looks like we could just say it's 4. How about over here? They say, what's the limit of this function when x approaches 2? Well, if you look at the low side, as we approach x equals 2 from the low side, it looks like the function is going to be 4. But when we approach it from the high side, looks like the function is going to be 2. So all of a sudden, when you come from the low and the high side, the functions are not the same. It's 4 and 2. So you say it's undefined, which makes sense when you look at the picture. You're coming like this, and you're coming like this. They don't have, they're not approaching a common point for the function. Where in this one, even though the graph is like 2 pieces, right here, they're still approaching the same point. So now, let me just do an example of if they give you a piecewise function and ask you to find the limit, what do you do? So here is how they write, here's how you write like a piecewise function. F of x, now f of x is going to change according to what the value of x is. That's what a piecewise function is. F of x is 2x plus 2 if x is less than or equal to 0. So this is the function sort of to the left of the y-axis. But to the right of the axis, the function equals x squared if x is greater than 0. So it's almost like at x equals 0 is a dividing line where sort of the function sort of changes. Now what they ask you for is what's the limit of this function when x approaches 0? So it turns out as x approaches sort of the dividing line, what's the limit of the function? So in this case, even though we have equations here, we actually have to determine the limit as x comes from the low side and the limit as x comes from the high side. So what we do is as x approaches 0 from the low side, the first thing we have to figure out is which function applies here. if x is coming from the low side, in other words, x is -3, then -2, then -1, which of these functions should we use? And then we look here and we realize this first function is what's used if x is less than or equal to 0. Well, that's what it means to approach 0 from the low side. So I'm going to use the first function. I'm going to plug in 0. So I'm going to plug in the number for x, and you get 2. So I'm saying the limit of the function as you approach 0 from the low side is 2. And I got that because this is the equation that applies when x is less than 0. However, now let's see what happens as we approach 0 from the high side. So now you figure out, well, which function am I using? So now x is like a positive number. And then you realize here the function equals x squared if x is greater than 0. So now I'm using the second function. And I go ahead and plug in my number for x, plug in 0, and you get 0 squared equals 0. So you notice for this function here, when you approach x equals 0 from the low side, the function is 2, but when you approach x equals 0 from the high side, the function is 0. I mean, actually, if I were to do a quick sketch, it looks something like this. I think it looks like this. Here is the graph of my function when x is less than or equal to 0. Here's the graph of my function when x is greater than 0. And I'm looking for the limit when x is 0. Here, when I approach from the low side, it's 2. When I approach from the high side, it's 0. And once again, if they don't approach the same point, then there is no limit. So for this one, you say the limit's undefined. Let's do one more quick piecewise example. And then we'll be done covering the limits when x approaches a number. So here's another one. So this one, once again, piecewise function. F of x equals 2x if x is less than or equal to 2, and then f of x equals x squared. So it looks like here, x equals 2 is my sort of dividing point where the function changes. So naturally what they want us to do, they want us to determine, okay, what's the limit as x approaches 2 of this function? So since it is a piecewise function, I'm going to have to calculate the limit coming from the low side and the limit coming from the high side, and if they happen to be the same, then I have a limit. If they're different, then I don't have a limit. So coming from the low side, so these are where the values of x are less than 2. So therefore I use this first function, and I'm going ahead, so I use the function 2x, I'm going to plug in a value of 2 for x. So the limit of the function, I should have put, the limit of the function as we approach it from the low side is 4. the limit of the function as we approach 2 from the high side. So now the values of x are greater than 2. So I have to use a second function. So I use x squared. So now I'm just going to go and plug in my number for x squared. So I plug in 2 for x squared. And I get 4. So I've determined when x approaches 2 from the low side, my function is 4. When x approaches 2 from the high side, my function is 4. Since these are the same, then I can say the limit as x approaches 2 of f of x equals 4. In other words, the first example, when you did your high and low limit, they were not the same numbers, so it means really, and this is what the picture looks like. For this one, it almost looks like, if I do a rough sketch, it's almost like it's like there's the first function, which is good from x up until 2. Then the second function kicks in. It looks like that. So in other words, these are two different functions. They look different. But if I'm looking at the limit, as x approaches 2, and I do it from the low side and the high side, you know what? They're approaching the same value. And once again, just to make it clear, my first one, when I approached x equals 0 from the low side, it was up here, from the high side down here. They're not approaching the same number, so it's undefined. All right, so that's how you calculate limits of functions mathematically. And even if they happen to give you a piecewise function, you now know how to do that. So the next lecture will be now looking at limits when x approaches infinity.